Alright, so today, as quick as possible, just a lesson in lighting. So here we have Artemis moon flyby. So here we have Artemis, the lit side of the moon, because the sun's behind these objects, right? And there's Earth, lit, lit. One thing I spotted before we get into the lighting is just the interesting movement of these objects. I want you to see this. It's just, not to mention the shape of the moon, which just proves, let's see if we can find it, the wide angle, right? Not even going into where they're actually at. But so there's the moon. You obviously have distortion, but with that distortion, look what happens. So at first, you have what? Earth going down this way, and moon coming this way. Moon coming towards Earth, Earth going down. Kind of like a T. Then, this lady pops up, and then we go like this. Down, but then, now they're kind of going towards each other, right? Actually, now the Earth is going up. And the moon's still coming at it. Wait a minute. So the moon is still going to the left. You see that? The moon goes left no matter what, right? See, here they are? It's kind of going left. Earth made a U-turn. Now, the angle did change a little bit, but the angle does not change nearly enough to make the Earth... fail. Go away. Make the Earth make that U-turn, see? Alright. Also, look at that. That's always the image. It always looks weird, and it's always covered in clouds. Anyway, so, lighting, lit, right? Lit, lit. Alright, makes sense. Sun's behind the objects. As with this setup. Sun's over there. Moon's right there. I have it centered on the moon, and then the Earth is over there. And the moon looks down further because it's got a 5-degree tilt, so it is here. Hard to show, but I have an accurate 5-degree tilt on that orbit. This is entirely to scale. It's not easy to do, finding a scale that would work, and I could not do the entire solar system. I made the solar system, and it's cool looking, but not at all useful. So I just did Earth, Moon, and Sun. And if you go to the Sun in my model, and then look out in the direction of Earth, let's see if we can find it. Yep, it is over there. So, you can't see anything. It's too tiny. So, interesting. Anyway, back to what we were looking at though. Let's go back. Light it back up. Magnitudes and everything I've tested on the brightness of the sun. So, there's a few things I want to show you. So, obviously what you just saw makes sense, right? If they're on this side of the moon, I can't zoom in, it's so tiny in my model. There's a few things that don't work when you put it to scale, unfortunately. So, makes sense. Now, another one I want to show you is this one. So the last one had the funny U thing, but, you know, lighting makes sense. This one, let's check this one out. This is Earth rising beyond the dark side of the moon. So the sun lit, moon not lit, Earth lit. They're behind the dark side of the moon, which means they're between the sun and the moon. Look at this. Also, same weird image where the Earth always is nothing but clouds. It's shocking anyone ever sees sunlight on that Earth. Anyway, Okay, you see my point? They're on the dark side of the moon. Okay, so if I'm on the dark side of the moon, one of two things is happening. If the moon's over here and I'm on the dark side of the moon, I see the sun. If I'm on the lit side, I see Earth. Okay, well, what about changing the orbit? Let's move this back to first position. Okay, if it's over here, let's get back on the moon. If the dark side of the moon is there, you have dark Earth and sun. And if I were to turn the other way, you would have the lit side and nothing. Okay? Dark side, sun in front. Light, light, sun behind. You cannot put a dark moon that direction, not to mention this side of the craft is lit and the side facing the Earth is dark. So why is the moon dark? How on earth did you get an Earth rising from the dark side of the moon? That is my major problem. The you on the other video, like, not sure what's going on there. Like, the moon did not switch to the other side to go towards the Earth. Didn't make sense. Earth can't make a U-turn, and if it's because you turned the camera, then the moon would have turned to the other side too. Okay, none of this makes sense. But another thing I want to show you that I have found playing with my model. Let's put this back. Oof, zoom out. It's too much. Alright, let's move my frame back over there. Alright, now at this point, it is on an angle that, let's go to Earth actually. So, there's your moon, Earth, sun. Interestingly, so clearly here you're not going to have an eclipse because the moon is lower, right? So if I'm here on the Earth, line it up with the sun, moon's lower, you're not going to have an eclipse. And yet, what do we know about the properties of light? How does light work on a sphere? The light ends up going around and creates that little circle there, but always has that little red light ring. You can always see a little bit. See? There's the Earth doing it. You don't ever get perfect darkness like the moon just goes away. You do, however, have cases where we've seen stars inside the crescent moon. I believe there's 51 recorded spottings of this. Well, not spottings, but actually recorded official recordings of this, whereas I'm sure there's probably been more spotted. So we can see stars. And if you haven't noticed, there's that crescent moon with the star in there, that symbol, right? That's a symbol for a reason. We have an instance where we can see stars through a solid object. Light goes past the edge of the spheres. You have dark, dark, light, or light, light, dark. You have U-turns. So, how do eclipses work then? So when an eclipse happens, you see this. The light goes around the edges, right? This moon is right in front of it, so the light goes around it. But we're talking about a light source that's 93 million miles away, which is why it affects this like this. The light is strong enough to go that far, and light wraps around a sphere. So how often should eclipses actually happen in the globe model? Right? Let's see if we can do this. The other thing, playing this is not very great. I could put the Earth going around, but it's going to be hard to track. So right now I have the Earth set here, and the moon's orbit is the only one I got going. Where'd my moon go? It's here somewhere. There it is. That's hard to track. Alright, let's look at that real quick. Just for the heck of it. What does it look like? Nope, let's go like this. Oh, I need to hit something other than that and get the marker off of it. Marker's still on it. Alright, moon. Alright. Let's hit Earth. There we go. Alright. You see that? Oh, it's so hard to see. You see how, even at that angle, there's ever so slightly hovering around, right? Ever so slightly. It's not until you get over here, right, that the ring disappears. But there is a phase when you rotate where you have this. So it would almost look like the moon as something eclipsing it. But there's no actual objects, like, in the way. Right? It's all about where it's located. So in this model, it seems to me that eclipses and the way the lighting would work in this model, we would see a lot more rare phenomena than what we do right now. You'd be seeing eclipses multiple times a month. You have, let's see. Let's bring it back. Okay, we're gonna go back to this mode. Alright. Bring the moon back over here. Well, actually, let's go around to try to center that. Alright, for the sake of being able to test out this eclipse thing in the easiest possible way, we are going to change this off of its degree and go take a look at the moon. It's not quite blocked here. So now I've lined up. Okay. There's sun, earth, moon to scale. You should. Okay. It's dark on this side. Obviously it's dark on this side, but what does it look like on this side? Wait a minute. No matter what I do here, I don't have an eclipse at a 2-scale model. Interesting. Now maybe one thing we can do is bring the moon closer to Earth, because perhaps the Earth is too far away to create that shadow. So let's try that real quick. Let's see. Quick little test. Now, it would make sense that a light source that is that far away and is bright enough to reach this distance, there would be enough surrounding light, considering the size. Obviously the moon's small. that orange dot, don't get confused by that. That's not the moon. But it wouldn't be shocking to me that an object right here would not cast a shadow if this is far enough away. Because light bends around objects, remember? That's why we had like a halo no matter what, you always have a bit of a halo until you're to like the side of the object, and then you can finally start seeing that disappear. So it actually makes sense to me why I can't, in a model that is accurate, get a shadow. But let's try to create a shadow. Let's see if the reason why is the distance, because I'm guessing that's what it is. So let's do this. And let's scale it. Let's try here. But we need to move that back over. Oh. Right there. Alright. That is still on the plane because I've lined everything up. So we've moved it closer. Okay. So it actually I moved the moon closer at like the regular size of Earth. It didn't work. So I made the Earth bigger. Massive. Let's see, I wonder what it looks like compared to the, oh wow. I mean, at this point, Earth is bigger than the sun, right? Okay, but I succeeded in finally making the moon dark. Actually, the whole side of this Earth is dark and it's scary, right? So, I can't even find it here. It's right here somewhere. It's dark. It's gone. Bye-bye moon. No light whatsoever. So there is a limit to how far an object can actually cast a shadow. It can't cast a shadow forever.
Let's explore what happens to an object's shadow when it is moved closer to and further away from a source of light. Here we have a flashlight and a lion. When we turn the flashlight on, a shadow is produced as the lion blocks the path of light. We'll move the lion further away from the source of light. The shadow is now smaller. What do you think will happen when we move the lion closer to the source of light? Yes, the shadow gets bigger. How do you think the shadow will change if we move the source of light instead of the object? Let's have a look. If we move the source of light closer towards the lion, the shadow grows bigger. If we move the flashlight further away from the lion, the shadow grows smaller.
Alright, so let's try. Now that the Earth is bigger, let's take the moon's orbit. And let's make it come out. We gotta keep track of the moon. Alright, so that big. Can we see it yet? Nope, not at all. Alright. Moon's orbit. Scale that up even further. Let's put it way the heck out. Yeah. It's a pretty big Earth, but I think at this point, because the Earth is bigger than the light, that's why we're having a problem. I think that's probably part of it. I think that's what it is, probably. I think if the object is smaller than the light, then the light's going to bend around it quite easily. But if the object is larger than the light, then yeah, we definitely see... Oh. Nope. We finally found a point where we back up enough. Here, let's get rid of that. You can finally see. Okay? So you back up far enough, eventually that light can't cast a shadow. A shadow cannot be cast infinitely far. It eventually fades, and it's dependent on the size of the object. So to recap, lighting correct, but look what happens, okay? Also, no matter where you stand, you're gonna either see light, just like this is lit, light, or dark. This is a problem. This is fake. Earth is not large enough to create a shadow all the way out to a small object, the moon, even on the plane. We tested that a minute ago. The shadow from an object cannot go forever. It gets smaller and smaller and smaller as you go back until you're no longer in the shadow and you have light again. Even still, the halo effect. Spheres create the halo effect. See that? You will have a crescent moon with a ring if it's a solid object. Until about here, and then it's finally a crescent. But you're gonna have crescent moons. You should have crescent moons that have that. We have a lot of problems, guys. This is to scale. Size and distance from the sun, just these objects and their orbital paths are to scale. Okay? We have problems. We need to deal with this. Alright, so what I've done now, after having tested both how big the Earth is and how big it would need to be in order to cast a shadow on the moon, changing the distance of the moon to the Earth, and then changing the brightness of the sun. So now what I've done is I've decided to add Pluto, because Pluto is pretty far away. So the sun would need to be able to cast light all the way out to Pluto. So what I've done, which actually, okay, so technically speaking, the orbit is correct. See if you can even see. Out there somewhere is the light. And yeah, stuff. It looks kind of like it's alone out here, to be honest. But I do have a little bit of light. The orbit is to scale. The size is slightly off. So it's slightly smaller than the moon. And when I tried to make it that small, it was just too difficult. So I made it the size of the moon. So it's a little bit off. It's 2/3 the size of the moon. So it's pretty close to the moon. So I just made it the size of the moon so that I can actually visualize this for you, because it was not coming through. But what I've done is I've changed the light. So we go to our light source and we can change the brightness. So I can change this. What do we have it at? 20 megawatts. I need to remember that. So let's change it to like 1 gigawatt. Okay, you see how bright it is? So my goal was basically to make it as light as possible. So if we go back to, let's say 10 megawatts. So very, very dim. We can go lighter, but then it's going to become dark. So I don't know, between 10 and 20, to where we would actually be able to take pictures of it and get clear enough footage, right? It's got to at least be somewhat lit. So it's lightly lit. My point is to see only enough. So actually, let's go to 10. It's to keep the sun as light as possible, but the sun's light still has to travel far enough to reach Pluto. So then we're going to go look at Earth closer to the light. Now that we know that the sun can light Pluto, we're going to go back over here. Yeah, that's a bit hot. Look at that ring. My goodness. Where's the moon? The moon's in my path somewhere. There, oh, over there? Yeah, there's the moon. Ooh, that moon is bright. I'd imagine that would be pretty interesting in the daytime too. Huh. Let's look at the moon. Zoom out so I can see what I'm doing here. This model is ridiculous. It's hard to work with. Alright, so we're gonna move the moon. Oh, if I can get it right. Oh. Let's go to the moon. Zoom in on it. Alright, let's try. There we go. Nice. That is a pretty cool effect. I would say eclipse, but it's not technically eclipsing, is it? So we still have the same problem. Not to mention, holy crap. So I guess they say when majority of the Earth is lit up, there you go. Doesn't quite match the half and half model, but wow. Look at that guy. He is shining bright as if they were lights of their own. My goodness. But yeah, we still have the same issue. Yeah, that's too much light. Can you imagine what that would be like living on something? That. I'm trying to... But again, it's got to be able to be bright enough to reach way the heck out to, you know, out there. This is why the lighting and the shadows just do not work on this model the way you would expect them to. And this is why we should have eclipses. Well, I guess it wouldn't be called an eclipse. We should have ringed moon more often because the light is so bright, it's shining on it that the light is wrapping around. What do you look at in the daytime when you go and look up the moon? When the sun and moon are in the same sky, remember? So a lot of times it looks mostly full, but you can see some more waxing and waning phases. But so this, let's move it. This would be daytime. So if the sun and moon are 93 million, or the sun's 93 million miles away, moon around like 226,235, you know, depending on where it's positioned. So a couple 100,000 miles versus 93 million miles. So if I'm here, anywhere on this face, really anywhere here, especially, I should be able to see sun and the moon. A lot of times you do see the sun and the moon in the same sky. Let's put the... Oh wait, we don't need to do that. We just need to go like this. Alright. Any of that would be daytime, right? Oh. Let's scoot out a little bit. Let's fix this. Alright. See, anywhere in here would be like daytime. So let's go really close to nighttime. Turn it. Look at it. Whew. Actually, let's go to the moon and zoom out. So from Earth, it would look like that in the daytime sky. It's still, whew, it looks very bright because, again, we're talking about the sun, its light. Lots of interesting things to consider. I have a lot more work to do. I'm going to be doing a lot more modeling and playing with things just to see what I can find, but that is it for today. So like, subscribe, hit that notification bell, share everything. Let's get to the truth. Peace out, guys.